Hello and welcome to another video on solving simultaneous equations, and in this video we're going to be looking at using the elimination method to solve these equations. And the whole reason why this is called the elimination method is because we're going to try and eliminate one of the variables, and in this case y, so that we're just left with x, so that then we can solve the equation. So if we first focus on this top equation here, we've got 6x plus y equals 18. Now I've represented that using a seesaw. So we've got 6x plus y on the left hand side and we've got 18 on the right hand side. And notice how the seesaw is level because these two things are exactly the same. There is an equal sign here, so these two expressions are the same. Now in order to eliminate the y's from our equation, what we can do is we can subtract this expression, 4x plus y, from this top expression. So let me just show you that. So if we're starting off with 6x plus y and we're taking away 4x plus y, well, what we're left with is 6x minus 4x, well, that just gives us 2x, and y subtract y, well, that is 0. Those two y's will just cancel out with each other. So if we represent what we've just done on our seesaw, well, we've taken away 4x plus y from the left hand side, and what are we left with? Well, we're just left with 2x. So on the left hand side of our seesaw, we're just left with 2x, so I can cross that off. Now if I just stop there, we have a problem. Okay, the scales will clearly not be balanced because I've just taken away something from the left hand side. So in order to keep the scales balanced, whatever I do to one side of an equation, we know I have to do exactly the same to the other side. So if I take away 4x plus y from the left hand side, well, theoretically, I need to take away 4x plus y from the right-hand side so the scales remain balanced. However, we do have a bit of an issue here. It will be quite tricky to take away 4x plus y from this side because we've only got 18. But there is a nice little trick we can do, and that is if we look at this equation here, we can see that 4x plus y is equal to 14. So what I can do is instead of taking away 4x plus y from this side over here, well, I can just take away 14 from this side and the scales will still be balanced because these two things in green are equal. We can just look here, these two expressions are equal. So if I take away 4x plus y from the left hand side, I can take away 14 from the right hand side and our scales will still be balanced. So 18 subtract 14, well, that is just 4. So now we've got 2x is equal to 4. And let's just do it over here. 18 minus 14 is 4. So now our equation is a lot simpler. All we've got left is 2x equals 4. And now we can solve this equation. We're left with x is equal to 2. Now let me just recap what I've done so far because it can sound a bit confusing the first time you hear it. So on the left hand side of my equation, I subtracted 4x plus y, and that was to eliminate the y's. Now on the right hand side of my equation, I subtracted 14. And you might be thinking, well, you can't subtract different things from both sides of the equation, but I haven't subtracted different things. I've subtracted exactly the same thing because notice 4x plus y is equal to 14. So although the expressions look different, they have exactly the same value. Okay, so another way to think about it is if you've got a tall, thin person that weighs, say, 70 kilograms, and you've got a short, fat person that weighs 70 kilograms, although they look different, they have exactly the same mass. So if we kick off the tall, thin person from the left-hand side of our seesaw, and we kick off the short, fat person from the right-hand side, well, the seesaw will still be balanced because they have exactly the same mass. Now, that may be a terrible analogy, but hopefully that makes sense. So after all of that, we're now left with x equals 2. And now to find the corresponding value for y, we can substitute our value for 2 into one of our equations. And it doesn't matter which equation we choose, let's just choose the bottom one. So focusing on the bottom equation, we've got 4 times x. Well, we know that x equals 2, so it's 4 times 2 plus y equals 14. Well, 4 times 2 is 8, so we're going to have 8 plus y equals 14. And now if we subtract 8 from both sides, we're left with y is equal to 6. So our two solutions are x equals 2 and y equals 6. Now I've got a couple more questions that we're going to go through, but before I go through these, I encourage you to pause the video and see if you can solve these pairs of simultaneous equations yourself first. Okay, let's go through them together now. So if we focus on this one over here, notice we've got 8x and 8x. So what we can do is we can eliminate the x's so that we're just left with y's. So how can we eliminate these? Well, we can subtract this expression from the top expression. So let's do that. So 8x subtract 8x, well, that will just cancel out. That's the whole reason why we're subtracting, is to get rid of the x's. And now we've got 7y subtract 2y, well, we're just left with 5y. So on the left hand side, we've got 5y. On the right hand side, remember, whatever we do to one side, we have to do exactly the same to the other. So if we're subtracting this expression from the left hand side, well, we can subtract 34 from the right hand side, and we'll be doing exactly the same thing because these two expressions are equal to one another. So 39 subtract 34, well, we're just left with 5. So now we've just got a much simpler equation. We've got 5y equals 5. So if we divide both sides by 5, we're just left with y is equal to 1. So now we've got our value for y, we can substitute this into one of our equations to work out the corresponding value for x. So let's do that. So let's choose the top equation. So we've got 8x plus 7 times y. Well, we know y is 1, so 7 times 1 is just 7, and that equals 39. So now if we subtract 7 from both sides, we're left with 8x is equal to 32. And now dividing both sides by 8, we get x is equal to 4. So we have found our solutions. Y is equal to 1 and x is equal to 4. Okay, let's look at this one now. So this time I can see that we've got the same number of y's. So instead of eliminating the x's like we did over here, I'm going to eliminate the y's. So if I subtract this expression from the top expression, just like we did before, 6x minus 2x, well, we're just left with 4x. And 2y subtract 2y, well, that's 0. Again, that's the whole reason why we're subtracting, is to get rid of the y's. Now if we look at the right hand side, we're going to subtract negative 10 from negative 26. So we just need to be really careful here with our negatives. So negative 26 subtract negative 10. Well, if we're subtracting a negative, that's the same as adding. So it's negative 26 plus 10. So negative 26 plus 10 is negative 16. So be really careful with your negatives. Okay, so now we've got 4x equals negative 16. Well, we can just divide both sides by 4. So let's make sure we put our equal sign here. We divide both sides by 4, we get x is equal to negative 4. So now we've got our value for x, we're going to substitute this in, and let's choose the bottom equation this time. So we've got 2 times x. Well, we know that x is negative 4, so it's going to be 2 times negative 4 plus 2y equals negative 10. So 2 times negative 4, well, that's negative 8. So we've got negative 8 plus 2y equals negative 10. Now let's get rid of this negative 8. So if we add 8 to both sides, we're just left with 2y is equal to negative 2. And now dividing both sides by 2, we get y is equal to negative 1. So the solutions to this pair of simultaneous equations is x equals negative 4 and y equals negative 1. Now I'm going to stop there for this video, but I've got lots more videos on solving simultaneous equations using this elimination method. So hopefully you'll join me in those videos and we can have some more fun with solving simultaneous equations. Take care.